Welcome to Ask and Learn.
So we're doing question number 78 of chapter 5 in Chemistry Essential Science. So diethyl ether C4H10NO, a flammable compound that's once used as surgical anesthetic, as is shown right here. The complete combustion of 1 mole of C4H10O to CO2 and H2O yields delta H minus 2723.7 kilojoules. Write a balance equation for the combustion of 1 mole of diethyl ether. And then we're going to use the information in the problem to calculate delta HF for diethyl ether. So if we're dealing with 1 mole of our diethyl ether, there's going to have a 1 in front of it. I'm just going to use a different color just to emphasize the answer. So we have 4 C's over here. We have 1 over here, so we have to add a 4 over here. Now we have 10 hydrogens here, 2 over here, so we have to add 5 because 5 times 2 is equal to 10. Now we have oxygens on the right. We have 8, and we have 5 over here, so we have 13 on the right. We have 3, and we have 1. We have 2 here. We have 1 here, so that's 3 on the left. So we're going to put this one aside. So we need 12 more oxygens. So we're going to put a 6 in front of here. And that's going to be our balance equation for 1 mole of diethyl ether. Next, we're going to find the delta H value. So remember, using Hess's law, delta H of reaction is equal to delta H of products minus delta H of reactants. So minus 2,723. In fact, let's just set it up like this. It'll make it less confusing. So remember, this is Hess's law. So now we're going to switch things around. So delta H R is equal to delta HP minus delta H reaction. So remember, since oxygen's an element in standard states, that's going to give us a delta H. Delta H is equal to 0 kilojoules per mole. So our only reactant is going to be our diethyl ether. So delta HF of our diethyl ether is going to equal to sum of the products minus the reaction. So we got 5 times negative 285.8 plus 4 times minus 393.5. Minus negative 273 minus 2723.7. So now we're going to put everything into our calculator. So delta HF for this reaction is going to be minus 279.1 0.3 kilojoules per mole. So that's going to be the delta H of formation for our diethyl ether.